Welcome back to the Deep Dive. You've given us the blueprints, the research, and the specs, and our job is, well, it's to give you that essential shortcut to being instantly well-informed. Today we're tackling technical architecture. I know that can feel a bit impenetrable sometimes, but we promise we're going straight to the core of how modern AI actually functions.
We are. We're diving deep into the infrastructure that supports something called the Model Context Protocol, or MCP.
Right.
And this is the framework that lets large language models, the LLMs, move beyond just predicting the next word. It lets them start doing things.
And for you, the learner, that's the key part, isn't it?
It is. Understanding this infrastructure is, it's the difference between knowing what an AI says and knowing how an AI acts.
So our mission today is really to look under the hood. We want to understand how this MCP infrastructure is built. We're focusing on the interplay between the central AI, these specialized servers, and external data.
All to deliver what they call seamless AI capabilities.
Exactly.
Yeah.
It's not about the algorithms today. It's about the plumbing, the stuff that makes those algorithms so powerful.
It really is the necessary framework. We focus so much on the AI model itself, like Claude AI in our example today. But that model is just a brain in a jar without this infrastructure. I mean, this whole architecture is the connection layer. It's what allows the AI to scale its abilities way beyond its training data. The connections, they're everything.
Okay, so let's unpack that. Let's start right at the very core. The figure running the whole show, we're calling it the MCP host.
Right.
And in this setup we're looking at, that host, the central brain, is Claude AI. So what is its job? It can't be doing every single thing itself, can it?
No, absolutely not. The host's role it's really about orchestration. Management.
All right.
Think of it less like a computer and more like a command center. It's the air traffic control.
Sure, it's directing things.
It's directing everything. Its main job is to manage all the communication in and out and act as the one primary interface for the whole operation.
So if Claude AI is the air traffic controller who is sending all the planes, that brings us to the MCP clients.
The clients, they're the systems or the apps that are actually starting the conversation.
So an application on my phone could be a client.
It could be, yeah. Or a customer service bot, a data analysis script. Anything that needs some AI function performed, they could be running in all sorts of different environments, but they all need to, request something from Claude AI.
So basically, if you're using an app that relies on Claude's power, that app is the client making the request.
That's it.
So the host Claude and the clients are the start and end points of any action you might ask the AI to do.
Exactly. And the key thing to realize here is just how complex the host's job is. When a client sends a request, say, analyze this document and update my database.
Right.
The host doesn't just process the text. It has to understand the intent of that request and then figure out how to route that demand to the right specialized resources to get it done.
And I imagine if Claude is getting thousands of requests from all these different clients, you need a really robust, common language to make sure nothing gets lost in translation. How do they all communicate reliably?
Well, that brings us to the MCP protocol, the communication highway.
Okay.
And this isn't just, a standard web protocol. It's a set of rules specifically designed for these high-level, complex interactions.
But wait, if the client and host are already talking over a network, why do you need this other dedicated layer? Doesn't that just add overhead?
That's a great question. It does add a layer of complexity, but what you gain is consistency and security.
I see.
The protocol manages so much more than just the request itself. It defines the standards for things like authentication tokens, session management, and all the routing info that Claude needs to confidently hand off that request to the right server.
So it's like a universal translator and a security guard rolled into one.
Pretty much. It makes sure that when Claude tells, say, server A, get data for client X, server A knows instantly that client X is allowed to have it and where to send the result. It just makes the whole thing seamless.
Okay, so just to summarize where we are, a client uses the protocol to send a request to the host, which is Claude AI. Claude then figures out what to do and routes it to the right specialized service.
Exactly.
And that brings us to the engine room, the part that gives Claude its power to actually do things.
This is where we see the AI shift from just answering questions to actually executing tasks. We move from the host to the specialized workforce. the MCP servers.
And the key here is that they're segmented, right? They're not all the same.
It's very intentional. These servers are not interchangeable. Each one has a very specific, optimized job based on the resource it manages. This is really the key to the system's flexibility and its fault tolerance.
Why is that segmentation so important? Why not just have one giant server do everything?
Because it lets the system scale specific needs independently. If your AI suddenly gets slammed with database queries, you only need to scale up MCP server A.
Ah, yeah.
And if, say, server B, the file system 1, happens to crash, well, your database and API connections are completely unaffected. It adds a lot of robustness.
That makes total sense. So let's break them down. Let's start with the structured data. That would be MCP server A, right?
Correct. MCP server A is all about data persistence and retrieval. Its only function is to connect to a database.
So its job is to give the AI access to real-time information.
Exactly. This is absolutely essential. If the client is a financial app, Claude needs server A to go fetch the latest stock prices or, a user's transaction history.
So it's the difference between Claude knowing what the world looked like when it was trained.
And knowing what the world looks like right now. Without server A, Claude is basically cut off from the system's living memory.
Right. Okay, so that's structured data rows, columns, facts. But
Yeah.
what about files? Documents, images, that kind of thing. That has to be MCP server B.
Yes. Server B's function is to interact with a dedicated file system. It handles all the input and output operations that are just critical for complex tasks.
So if I upload a big PDF for it to analyze.
Server B manages the secure reading of that document. And if Claude generates a report at the end, Server B manages writing and saving that file to the right place.
This feels like it's a huge deal for security, too.
It is.
Because instead of the main Claude model having, free reign over the entire file system.
The access is all mediated and logged through this one specialized server. It creates a security boundary. Server B is the only part of the system that should be allowed to touch the files, and it generally does it on explicit instructions from the host. It really simplifies the security.
Okay, now we get to the last one. And this is where the infrastructure really lets Claude step outside its own box and act on the world.
Yes.
Here's where it gets really interesting. Tell us about MCP server C.
Server C is the game changer. It's the link to, almost infinite possibility. Its whole job is to connect directly to external web APIs.
So this is how the AI's functionality gets extended.
It's how it integrates with services it was never even trained on. It's like giving Claude hands to interact with the world.
And we're not just talking about pulling in data, like with server A in the database. This is about performing actions, right?
This is about actions. It means Claude, through server C, can execute API calls that actually trigger things on external platforms. The source material gives a really powerful example.
Which is?
Interacting with services like GitHub.
Okay, wait, let's just pause there, because that feels like the core takeaway from this whole deep dive.
I think it is.
This infrastructure isn't just for faster Q&A. It moves Claude from being this passive oracle into an active agent that you can delegate real-world authority to.
That is the essential insight. A client asks for an action, Claude routes the instruction to server C, and then server C executes that action on GitHub using its API.
So the segmented architecture lets the AI become, what, tool-oriented?
Exactly. It means the AI is no longer limited by its training data. It's limited only by the permissions and the APIs that server C is allowed to access. It can interact with the outside world in a really structured, manageable way.
This just fundamentally changes what you can expect from an AI. I mean, it's the difference between asking, how do I fix this bug in my code?
Right.
And telling it, please fix this bug and push the correction to the staging branch on GitHub. Server C is what makes that second one even possible.
And that specialization is what allows Claude to deliver those seamless AI capabilities. It's an infrastructure built for action.
Okay, so for you, the learner, let's just quickly recap this whole architecture.
Yeah.
At the center, you have the MCP host, Claude AI, acting as the dispatcher.
It manages communication with the clients, all using the standardized MCP protocol.
And the real work gets done by the specialized MCP servers. Server A for databases.
Server B for file systems.
And the really crucial action-oriented server C for external web APIs, including platforms like GitHub.
And that structure is what creates this powerful, flexible system, because Claude can expand its abilities just by integrating a new API through server C without needing to retrain the whole core model.
And that flexibility leads us to our final provocative thought for you to mull over. We've seen that this lets Claude interact with file systems, manage data, and crucially, perform actions on platforms like GitHub.
Which raises a really important question. If an AI's ability is now defined by the external systems it can connect to, then the MCP protocol isn't just a communication layer, it's the boundary of the AI's influence. So how does defining the scope of that protocol, what APIs Server-C is allowed to use, how does that shape the limits of an AI's power in the real world?
It completely changes how you think about AI. You're not just querying a brain anymore. You're delegating tasks to a whole system of specialized agents.
Yeah.
And when you think about the implications, if an AI has access to your file system in your GitHub, it's fundamentally woven into your workflow.
And your sensitive data. Understanding this architecture means understanding how much power you're really handing over.
Knowledge is most valuable when you understand and apply it, especially with these systems.
I agree.
Absolutely. Thank you for joining us on this deep dive into the actionable infrastructure of the Model Context Protocol. We'll see you next time.